Today. I've been talking about circles and central angles and chords and tangents and arc lengths and all of those different types of things. Bags underneath my eyes today. I'm a little tired. Um, let's get going. Question 1 says, find the measure of the arc or central angle indicated. Assume the lines which appear to be diameters are actual diameters. Perfect. All right. So I just go in and do everything I know. I'm not really even looking at the question yet. I'm going to just kind of go in and figure out if there's any arcs in here that I don't have. So I know that this is 45 because they're the same as the central angles. So I know that one has to be 45, and then I know all those angles have to be corresponding. So this is 85, this is 115, it's a nice 115, 35, and 80. Not much left for me to know. Now it wants to know the length of the arc EDB. So it's 3 letters, so I know it has to be more than 180 degrees. Adjust this a little bit, go like that maybe. That probably helped. EDB, so there's E, there's D, and there's B. So I've got 85 plus 115 plus 35. Take out the calculator. 85 plus 115 plus 35. It's 235. So the measure of that angle is 235. 235 degrees. Pretty straightforward. Question number 1. Question number 2. Again, I'm going to go ahead and figure out everything I can figure out here. So I know this is 55. I've got a diameter sitting right here. So since I have a diameter sitting right there, I know those 3 angles have to add up to 180. So if I go 180 minus 60 minus 55, that tells me that this is 65. So this is 60, this is 65. These 2 angles, these 2 sides create vertical angles, so this has to be 65, making this 65. And this right here is a diameter. So if I go 180 minus 65, that's going to be 115. So that's 115. I got everything filled out. I need to know angle J, F, K. Did more than I needed to do, but that's okay. Answer for this is 60. You're done. Question number 3. Okay, again, gonna know what I know. That's 60. That's 80. Looks like I've got another diameter right here. So if I go 180 minus 80 minus 60, it's going to give me 40. Notice I have another diameter here. So if I go 180 minus 60 minus 40, that's 80. I guess I could have done vertical angles there too. Those 2 angles are vertical angles, so they have to be congruent to each other. And that's 80, so that makes this one 100. I need to know an arc, so that I'm going to put my arc lengths here. They're the same as the central angle. I'm going to start at D. I have to go to F next, and then all the way over to C. So there's 2 ways I could do this. I could go, sorry, I got a phone call, a little bit of a disruption in there. If you see an edit, a cut, a slip, maybe I missed a little bit something, phone rang. So kind of back to explaining, I don't know where it cut off, I guess. So there's 2 ways to do this. I can look at this whole thing and add all of those numbers up, or just notice that that piece is clipped off, so that's what I'm going to do. I'm just going to go 360 minus 80. Math is easier. So the answer is 280 degrees for the measure of the arc. Number 4. Again, just kind of going in and putting in what I can put in. Again, I notice there's a diameter here, and then I've got vertical angles sitting there. So if I go 180 minus 119, that's 61. I should probably write it in an actual pen. That's 61, that's 61. These are vertical angles, so that's 61. And we've got another diameter there. So I can go 180 minus 54 minus 61. You heard a little hesitation in there. I looked up to see what the question was and realized I'm doing probably more work than needs to be done right now, because the answer is just KL, which is right there. So I had the answer already. Whatever. I like to do more sometimes. Whatever. All right, number 5, it says find the length of the arc. So we got no formula for length of the arc. Arc length, we'll put this on the computer. So arc length is equal to, arc length is the distance around, you're traveling around the circle. So when you travel completely around a circle, it's the radius. So that's 2 pi r, and then it's the part of the circle that you're traveling, which is your central angle, over 360. So in this case, it's 2 pi times 15. And then we're going to take that times 150 over 360. Multiply that out. 2 times pi times 15. And then I'm going to take that times 150 divided by 360. And I get 39.3 inches. And that's your answer. Number 6. Okay, same formula. So I'm going to go 2 pi times 12 times 225 over 360. So 2 times pi times 12 times 225 divided by 360, 47.1 yards. There you go. Number 7, now it's telling us to find the area of the sector. So we want to find the area really of this part of the circle. So the area of a sector is equal to the area of a circle, which is pi r squared, times the percentage of the circle that you're using over 360. So in this case, our radius is 15. So it's pi times 15 squared times theta, which I covered up there, 285 over 360. So pi times 15 squared times 285 divided by 360, 559.6 centimeters squared. Number 8. So pi times 10 squared times 240 over 360. This is the area that I want to find. So pi, pi times 10 squared times 240 divided by 360. 209 is what I got. 209.4 kilometers squared. Kilometers. My favorite questions. Determine if a line AB is tangent to a circle. So in order for it to be tangent to a circle, in order for this line to be tangent to the circle, in order for this line to be a tangent, meaning it only hits it in one spot, we have to have a right angle there. So we have this right triangle right here. So if we have a right triangle, if we use a squared plus b squared equals c squared, leg squared plus leg squared equals hypotenuse squared, if that works, we're good to go. So our legs, so the leg is this whole distance right here. So it tells us that the radius is 8, so that makes this 8. So this whole thing is 16. So I have to go 16 squared, and that's one of my legs. 14 squared is the other one. Hypotenuse, it looks like we have everything. So that's 20 squared. The 16 squared is 256. 14 squared is 196. 20 squared is 400. 256 plus 196 equals 452, which is not 400. So that is not nice. I'll work on my penmanship one of these days. I think I probably say that every video. It's not tangent. Since they're not equal, it's not tangent. Number 10, same concept. We want to know if AB is tangent, so I have to show that that's a right angle. So I need leg squared, so they give me that leg is 11. They give me that leg is 9.6. So 11 squared plus 9.6 squared, that has to equal this whole thing. Well, this is 5. This distance right here, that's my radius, so that's 9.6. So my whole hypotenuse is going to be 5 plus 9.6, which is 14.6. So 11 squared is 121. 9.6 squared is 92.16. 14.6 squared is 213.16. Add 121 plus 92.16. And my guess is you get 213.16, which of course is equal to 213.16. So this is a tangent. And we're done. Number 11, find the segment length, assume that the lines that appear to be tangent are tangent. Okay, now they're telling us it's a tangent, so we know we have a right angle there. We have to find the missing side. So we use Pythagorean theorem again. That's the hypotenuse. So 16.5 squared plus 8.8 squared. That's going to equal x squared. So 16.5 squared. That's 272.25. 8.8 squared is 77.44. That's equal to x squared. Add those two together. You get 349.69. That's equal to x squared. Take the square root. Round to the nearest tenth. 18.7 units. 18.7. Number 12. Same directions. We have to find this one, so I'm going to put an x there. So that's one of my legs. So I've got 8 squared plus x squared has to equal the hypotenuse. Well, this is 9. The hypotenuse is the whole thing. That's a radius, so I know that's 8. So that whole thing is 17. 17 squared. 8 squared is 64. 17 squared is, I should know that, 289. I'm going to subtract 64. So x squared equals 225. One of them that I know. Square root of 225 is 15, I think. It is. It's 15. And that's our solution. On to number 13. How many do we have? We have 20 total. We're getting there. Number 13. Find the perimeter of the polygon. Tangent lines. Remember tangent lines. I like these. These are my favorite. I think I said that. So anyway, so if we have a point, it's two tangents, they're congruent to each other. So this has to be 4.6. I know the whole thing is 12.6, so if I go 12.6 minus 4.6, it's going to tell me that that's 8. Well, that's the tangent for there and there, so that has to be 8. Use the same concept to find this one. 13.7 minus 8, that's 5.7, making this 5.7. Now, when we're talking about perimeter, we're talking about adding them all up. So that's 4.6. There are two of those, so plus 4.6 plus 2 of the 5.7s plus 8 plus 8. Add all of those things together, you get 36.6. I looked at the answers instead of punching it in my calculator. Number 14, all right, I got a 4.8 there, so I know that's 4.8. I got that whole thing this whole thing is 15.6, so if I go 15.6 minus 4.8, I get 10.8, making this one 10.8. I know this part is 10.8, the whole thing is 21.8, so 21.8 minus 10.8, which I should probably be able to do in my head, you get 11 and 11. Add all of that up. I'm not going to write it all down this time. I'm just going to look at the answer anyway. Add all of that up. 4.8 plus 4.8 plus 11 plus 11 plus 10.8, 10.8. You get 53.2 for your solution. Okay. On to the next page. Solve for x. Assume that they're tangents. Okay, I can do that. So if they're tangents, so that means that this and this are tangent lines. So if they're tangent to each other, 2x minus 11 has to equal x minus 3. I'm going to subtract x. That gives me x minus 11 equals negative 3. Going to add 11. Get x is equal to 8. 3.2, irrelevant. Number 16, I've got two tangent lines here and here. I know tangent lines are congruent. So 3x minus 7 is equal to 2x. I'm going to subtract 3x. So negative 7 equals negative x. Divide by negative 1. 7 is equal to x. And that's our solution, and we're done. 4 more. The fun stuff. Find the length of the segment indicated. Round your answers to the nearest tenth if necessary. All right, so kind of look at what I have. So I have a radius perpendicular to a chord. So I've got a right angle there. So I know that these two pieces are congruent. That's 13.9. I don't know if that helps me. Probably doesn't. But I know it is. That's true. I have this distance is 10.1. I have the whole diameter is 34.4. So if I take 34.4 and divide that by 2, that's going to give me the radius, which is 17.2. So I know my radius is 17.2. I want to find this right here. Well, I notice that my radius is right here, and my radius has to be 17.2. I already know 10.1 of it. If I take then 17, use a pin, that's what I'm trying to do. If I take my pen then and I go my radius 17.2 minus 10.1, that should give me my solution, which is 7.1. Break them down. Take your time. Number 18, again, looking what I have. I know my radius here is 13.8. I've got a radius, so I've got a perpendicular, so that makes this a right triangle. I know this distance here is 8.1. So in my right triangle, I know one of the legs is 8.1. I know the hypotenuse. This part right here, because this is a chord perpendicular to there, these two pieces have to be congruent to each other. So that makes that x as well. So now I have this right triangle sitting right here. So to find the value of x, I can use the Pythagorean theorem. 8.1 squared, that's leg squared. My other leg is x, so x squared equals 13.8 squared. 8.1 squared is 65.61 plus x squared equals 13.8 squared, 190.44. I'm going to go ahead and subtract 65.61. I get x squared equals 124.83. If I take the square root of that, 11.2. And that's what the answer key said, which is good. Number 19. Just looking at it, see what I got. So I've got a radius here is 12. So that makes that has to be 12 because it's another radius. It tells me that this is 10.8. I notice that that's perpendicular. So that makes this a right triangle. So I know this leg is 10.8. That leg is what I have to find. And I know this hypotenuse is 12. So there it is. So x squared plus 10.8 squared equals 12 squared. 10.8, I should hit 10.8 instead. 10.8 squared. So x squared plus 116.64. Didn't we just have that? Maybe not. Equals 12 squared is 144. Gonna subtract 116.64. 144 minus 116.64. So x squared equals 27.36. Take the square root of that. 5.2. X is equal to 5.2. Nice point. 5.2. And the last one. All right, so I know this radius is 12. So I know that distance has to be 12. I know this distance is 10.4. I have to find this distance right here. But I know this whole distance is 12. So if I can find this distance right here, I know that y plus x has to equal 12. So if I draw that right there, I've drawn a radius. I know that radius is 12. I've got a right angle there, so that means I've got this right triangle sitting right here. So I can use that right triangle to find y, and then I can subtract that from 12, and I've got it. So Pythagorean theorem again. So y squared plus 10.4 squared has to equal 12 squared. It's 10.8 last time. So y squared plus 10.4, 108.16. 12 squared is still 144. I'm going to subtract 108.16. That gives me y squared equals 35.84. If I take the square root of that, I get 6. I get 5.98, so I'll just call it 6. So say y is equal to 6. So So if y is equal to 6, that makes this distance 6. What plus 6? And we got to find our x value. So 6 plus 6 is 12, so x is equal to 6 as well. And that is the last page. Bit of a long video. Good luck on your test, everybody. See you next time.